In this module, we'll be talking about a few other measures that help us to describe our data. More specifically, we will talk about quantiles. Since we already know that mean and median are the special cases of a family of parameters known as location parameters, and these are the parameters which also help us to describe the center of our data along x-axis if we plot them. Other location parameters which help us to determine the position of a particular observation in data are called measures of position. These measures of position help us to divide the sample data into n equal parts or divide the probability distribution into contiguous intervals with equal probabilities are called quintiles. So if you look at these three different histograms which shows a symmetric, a positively skewed, and a negatively skewed data. Over here, these values, mean, median, and mode are the values on the x-axis, and same is true with the measures of position. There are different types of measures of position, which are called quartiles, deciles, and percentiles. In general, if we say we want to do skew quantiles, then these are such q-1 values that can help us to divide our data into q subsets of equal size. These quantiles are also called cut points. The most simplest and well-known cut point that we have already discussed is median. Let's look at that if this number line represents our data, then to divide the data into two exact equal parts, we need to cut this data from one point, and that is a median. But in case if we want to divide our data into further different parts, let's say into three equal parts, we need to make two cuts that divides our data into three equal parts. Similarly, if we divide our data into four equal parts, we call it quartiles. Quartiles word comes from the quarters, where each quarter contains 25% of the data within it. So in general, we define the quartiles as in an array. These are three cut points that divides the data into four equal parts, which are in general represented by qk, where k is the kth value. K will be 1 if we talk about quartile 1, k will be 2 if we talk about quartile 2, and k will be 3 if we talk about quartile 3. Here, qk is, if you look at its formula, qk is divided by 4, since we are dividing our data into four equal parts. N denotes the number of observations. One more thing that's important to mention over here is that quartiles act the same way as we calculate the median. We always look for an index value, and the value of our data that's equivalent to this quartile value is called our respective quartile. Like over here, this value is Q1, which is also called lower quartile. This value is Q2, which is called median. And this value is Q3, which is also called upper quartile. You will notice that here in quartile 1, value of k turned out to be 1. In quartile 2, the value of k turned out to be 2, and the same is the case with the third quartile. Let's look at the method of determining quartiles. The first of all, since we already know that if we want to divide it into equal parts like median, we need to arrange the data into ascending order. Then in the second step, we'll assign an index to each data point. In the third step, we try to find the position of respective quartile using the formula qk equals to k times n plus 1 by 4, when k could be 1, 2, and 3. So in the fourth step, we identify the value of the quartile, and we move on that if a quartile lies on an observation, then the value of quartile is the value that is against that observation. But if by any chance it lies between two observations, then we take the lower value and specified fraction of that value to be considered as our quartile value in our data. Let's take an example where we have this data that contains 9 different observations. To calculate quartiles, let's say to calculate first quartile, we need to order the data into an ascending order. Since this data has already been ordered, we'll directly go and find out the value of the Q1, and it turned out to be 2.5th value, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2.5th value is going to be our first quartile. Since this is exactly 0.5, we can simply take the average of lower value and an upper value to calculate the value that's exactly in the middle. And it turned out to be 36. And for the same is the case with the second quartile. Second quartile turned out to be 5th value, and 5th value is also a median. And third quartile turned out to be 7.5th value, which lies right here. This is 7.5th, which is again exactly into the middle of these two values. Therefore, we take the average of both values. We can also use the other method where we can take the specified correction added to the difference of observations. So in this data, we got lower quartile, that is 36, upper quartile, that is 58, and a median, that is 43. If we look at this different pictures, over here, this first diagram, this represents a uniform distribution. In this uniform distribution, we can see that it has 25% observation below quartile 1, 25 between quartile 1 and quartile 2, 25 between quartile 2 and quartile 3, and 25 are above quartile 3. In aggregate, we can say that below quartile 3, there is 75% observations. And similarly, below median, there are 50% observations. And below Q1, they're 25%. And likewise, on their above side as well. So Q3 has 25% above it. Q1 has 75% above it. But over here, when the distribution is very symmetric or uniform, we can see that the areas are apparently the same all over. But it's not always true, because when the data is skewed, you may see that Q2 and Q3 are not quite equidistant from each other, from Q2. Then if we divide our data into 10 equal parts, it's called deciles, where if on a number line, we can see the D1 represents first decile, D2 represents second decile, D9 represents ninth decile, and D5 is some value that has 50% data below it. All these deciles has 10% below it, D2 has 20% below it, and so on. D9 has 90% data below it and 10% above it. So deciles are denoted by dk, where k is the value that can go from 1 to up till 9. So there will be 9 such values that divide the data into 10 equal parts. So in this histogram, we can see that if D1 is a cut point that divides the data into the part where it has 10% observations below it and 90% observations above it, then this point is D1. And this is exactly a point which is approximately 17 or 17.5 that has 10% observations below it. So from here, we can say if these are the marks out of 60, then we can say that 10% people have marks below 17.5, whereas there are 90% people who obtained the marks below marks above it. And same is the case. I mean, we can notice that wherever the frequencies are higher, the difference between the deciles is very, very minute as compared to the first one along the tail. The difference between deciles is much bigger. So this is how we divide our data into 10 equal parts, and this is how we interpret it. Thank you.